This is an introductory video for Moment of Inertia Lab for Physics 1050. In this lab, we're going to be finding the moment of inertia of this solid metal disc. So that's our objective for the lab, is to find that moment of inertia. Let's just go through a very quick bit of the theory as a recap for your lab. So in this lab, we're going to apply Newton's second law in rotation, which says that the net torque acting on an object is its moment of inertia times its angular acceleration. So sum of the torques, that's a symbol tau, it's a Greek letter, that's torque. Torque is R times F times sine theta. R in this case is going to be the radius of the wheel, F is going to be the attention applied to it, and theta is going to be 90 degrees. I is the moment of inertia for a disc. Moment of inertia has a known or calculated value of 1/2 times its mass times r squared. Alpha is the angular acceleration. Alpha, let's see, why don't we write that down? Angular acceleration. Alpha is the linear acceleration divided by the radius of our wheel. Torque has units of newtons times meters. Angular acceleration has units of radians per second squared, or simply seconds to the -2. So we're going to apply a known force, calculate our torque. We're going to measure our acceleration, calculate our angular acceleration alpha. We're going to plot torque as a function of angular acceleration and try and find our moment of inertia. So let's have a look at the apparatus and our setup. So our apparatus in this experiment is our wheel, which is attached to a solid base. We have a photo gate with its cord, a clamp, what we call some bar tape. It's plastic tape with some black rectangles on it. We have a mass set and we have a little piece of tape. The very first thing to do in this experiment is to loosen the wheel from the base. We'll just unscrew this thumb screw. We'll take this to a digital balance or a triple beam balance and get the mass. Please do be careful you don't drop it on your toes. You could really hurt yourself. So you'll get the mass and record that. You should make your measurements in SI units. And then you'll use a ruler or a meter stick and we'll measure the radius of the disc. So we'll want the mass and the radius. Once you've done those measurements, put the wheel back on the base. As you tighten up the screw, we want to tighten it enough so that the wheel rotates freely, but it doesn't wobble back and forth. Okay, mine looks pretty good. Next, we're going to attach the photo gate. We're going to attach the photo gate to the bench using a clamp. So the clamp can just screw onto the bench. Tighten that in place there. If you look at your photo gate, you'll see it has a place where this can attach to the screw that comes off the clamp. So we'll just put that in there and tighten it up. Oh, before we put that on, let's just take a quick look at the photo gate. Make sure we understand how that works. The first thing I'll show you about the photo gate is that some of them have a little shutter on the inside, and the shutter opens and closes this little hole here. We want the shutter to be open, so if yours has a shutter, make sure it's open. And the way the photo gate works is the beam comes out one side through the little hole and it gets received on the other side. So this is where all the action happens. The beam comes out here and it goes in there. So that's going to be important. Okay, let's attach our photo gate now. Not every photo gate has the shutter, but the big thick ones do, the skinny ones don't. Okay, that's on there nice and secure. Then we'll take the cable from the photo gate and we'll attach that to our Lab Pro. Yours might be in a big tangle, just like mine is. If we look at your lab instructions, it will say to attach the photo gate cord into channel number 1 of your Lab Pro. So we'll find, oh nope, sorry, it says DigSonic number 1. So we'll attach that, click that in place. Now that's all hooked up. Next, we want to attach our bar tape to the wheel. For this part, I'm going to suggest you use a small piece of tape only. If you use a lot of tape, sometimes that's going to interfere with your results. So I've only taken a small piece of narrow tape. I'm going to put the bar tape right on top and just hold that in place with my piece of tape. I'm trying to keep my piece of tape right on the top of the wheel. Okay, next I'm going to line things up. I'm going to bring my wheel forward as far as I can. And I want to have it so that my bar tape falls right in front of that sensor on the photo gate. Okay, now we're all set up and ready to collect our data. So let's see if we can take some data. The instructions say to first hang 30 grams from the bar tape. So we'll just tighten that on the wheel. And at one end of the bar tape, there's a little hole punched in it. This is going to be so much easier if you have a partner, another set of hands. So I'm going to take a 20-gram mass and a 10-gram mass, put those both on, double checking my alignment to make sure my tape is right in the front. If you want to make sure you got it, you might see that your motion sensor will blink as you move up and down. So it blinks when the beam is broken. So if your light is blinking when your bar tape is in front of it, you have done it exactly right. Okay, so we're all set up. We're good to go. Let's go ahead and open up our Logger Pro. So we'll open that here. Takes a moment to open. Once we're ready, our bar tape and our masses are aligned, we'll hit collect. And then it'll pop up waiting for data. Now it's time for you to release it. We'll let that go. Catch it just before it hits the floor, and then we can hit stop. Okay, so this is our data set. If we look at the data, our distance versus time graph is a curve that tells us we have an acceleration. We'd like to calculate the acceleration. So what we'll do is we'll highlight the linear portion of the velocity versus time graph. Super important that you only highlight the linear bit. Then we'll do a linear fit. And why don't I click on that and make it a little bit bigger? Hopefully you can see it. For this part, we don't need to have the uncertainty. Our uncertainty is going to come later. So right here, it gives us the slope 0.4568 meters per second. So that means that when my hanging mass was 30 grams, my slope or my acceleration is 0.4568 meters per second squared. Okay, you'll take off your 30 grams, put on 40, repeat, find your acceleration, keep going 10 grams at a time until you reach 100 grams, and you completely fill up your table with your hanging mass data and your acceleration data. Once you have that table of data, we'll move on to the analysis portion, and we'll go over that in a separate video.